Hey y'all, good morning. Welcome to the channel. So today I'm happy to answer the first meaningful and interesting question that I got, well, since I started asking for meaningful and interesting questions. So I wake up to Castle Racing asking on my video, hey Greg, first video of yours that I've been recommended and a wonderful chance to speak with you. Castle Racing? Welcome to the channel. Glad to have you. Studying non-equilibrium systems seems to require a different way of thinking than classical physics. Does working in this field shift your philosophical view on how ordered or chaotic biological systems actually are? That's a deep, packed question. You know, imagine a lake. No wind, beautiful day, pristine, clear lake. And you throw in a rock. You disturb the system. It's out of its equilibrium. But individually, every, bit of the rock, bit of the water that it hits, the waves that are generated, all of that can be described. And even though you've disturbed the system and you brought it out of its equilibrium, the whole thing can be pretty clearly understood, don't you agree? So yes, I spent a lot of time working in non-equilibrium physical systems like electric discharges, plasmas, but I don't view them as anything outside of the ordinary, if that makes any sense. Biological systems too. I've heard many describe biological systems as chaotic or disordered. I mean, it all boils down to biochemistry, which I also find to be pretty straightforward. Plus, attracts to minus. So you look at a molecule and you find the positive center, and you look at another molecule and you find negative center, and you know that's where they're going to react. So to me, let's read your question again. Studying non-equilibrium systems seems to require a different way of thinking than classical physics. Perhaps, back to my example of the lake, right? So classical physics, you have a ball rolling down a perfectly triangular hill. How's that different from me throwing a very complexly shaped rock into a very flat lake? So maybe, you have to understand that the system can be out of equilibrium, strongly out of equilibrium, like electron temperatures being 1,000, 10,000 times higher than the temperature of surrounding medium. Yeah, sure. But those electrons will interact with more passive electrons. They will transfer energy. They will, like a tennis ball with a brick wall, they can, collide with the wall and bounce off, or collide with the wall and knock out a little piece of pebble, or collide with the wall and stick. So yeah, I think while it's a complex question, the simple answer is yes, it requires a different way of thinking than classical physics, in a way that maybe some of the formulas will be different, but the thinking itself, just the process of dissecting the problem, analyzing it, and digging into it to find the solution, that process is the same, regardless whether you're in biological system, in non-equilibrium plasma system, or in classical mechanics. Well, moving on. I love knowledge sharing, so I try to take advantage myself and learn when I can. Thank you, and I hope you have a great day. Well, thank you. You asked an awesome question. I love learning. That's why I'm doing this. doing this, especially doing this regularly, forces me to try to communicate with humans other than a mirror or keyboard for a scientific publication. It's very good. Thank you for coming here. Thank you for asking meaningful and thoughtful questions. I enjoy doing this. I hope you enjoy watching this. Please ask me anything you like, and I'll see you in the next one. Take care.